When we started this project, the client is the state, and they made it very clear. The system cannot go down because there are people who rely paycheck to paycheck, not just both payroll, but also pension. So that added like an extra level of pressure to us when we kept on thinking about it. But with that, I'll turn it over to Chris, who is our practice leader for the digital and app innovation.
Sure. Yes, thanks, Jason. And I think the mic works. So yeah, Chris Peachman, the longtime Microsoft MVP, originally awarded in 2008. Mostly development background, but I've done infrastructure and data design and architecture over the years. As Jason said, I'm practice lead for the digital app innovation practice with us. So I'll talk about technical debt, kind of using GitHub Copilot and AI for modernization. So mission critical systems, Jason said this was a client with a state agency, kind of high stakes, basically, payroll and pension processing system. So zero tolerance for failure, has decades old code. So the original system is a mainframe, natural out-of-box system that goes back 30 years or so. So they need to modernize the application using modern tools, modern systems, shed some of that legacy tech debt in a manageable way. So looking at the tech debt of the system, I mentioned this natural out-of-box code base. Uses JCL jobs for background batch processing, ETL transformation, things like that. They had very little documentation, as in a lot of IT systems. The code basically is the documentation, especially as the system gets older and the written documentation gets more outdated and sometimes even lost. And then the SMEs, you have shrinking pool of experts on the system. Eventually, nobody remembers why things were implemented the way they were, right? Even they have to look up the code to see what it's doing and why. So, the impact of that on updating the system, modernization, things like that would be, it's slower to make changes. It's harder to onboard resources on the project, and it adds growing operational risk. A lot of times, some of these older systems have had multiple attempts to modernize, and then sometimes there's challenges that end up causing pause and put off, so then you have a system that lasts maybe 10, 15 years more than what it was originally thought it would, possibly longer. And that kind of gets to the do nothing trajectory of, well, this is too hard, it works as it is, let's just leave it. We don't want to change it if it's not broke. But legacy systems like this, you have increased risk and failure with aging hardware, increasing licensing costs from vendors, like in IBM, software AG, things like that in the mainframe space. Over time makes it more difficult to maintain the existing system. So with the modernization, kind of why Microsoft and Azure? So right now it's the cloud is the modern platform of choice, right? It's proven at government scale. We have Azure Gov Cloud. There's also the Azure Public Cloud. Depending on the project in the government space, you can use either one, depending on the regulation requirements. It has security, compliance, and auditability features built in to the platform and able to be integrated. Better ways that you can do that in the cloud than you used to be able to. And then the native AI integration with all of the Azure services, with the AI Foundry to the developer tools like GitHub Copilot that we'll focus on here, kind of built into the platform first class. So our tools that we decided to use for the solution, on the infrastructure side, using Azure App Service, like Azure Functions, to host some of this implementation of a scheduling system that needed to be replicated from mainframe capabilities. Using Azure Kubernetes Service to host containerized instances of .NET application. These are things that will help us scale in the cloud. Using Azure SQL Managed Instance gives us a high compatibility with Azure SQL capabilities. Also, kind of peace of mind safety a little bit in creating repos in GitHub. Accidentally create a public repo that can be problematic, to put it simply, sometimes. And then GitHub Copilot, so the AI capabilities of GitHub to enhance the development team. So looking at what is Copilot, what it isn't. It's not kind of easy button. You just push the button and it does the work. So looking at like legacy modernization, taking that legacy code, in this case natural, and want to convert that to C#. For instance, you can't just tell Copilot, here's my code, make me an application that does the same thing, and it just does it. It's a bit more complicated than that. You can't really replace the developers, but you can enhance them. You can have your team of developers be able to be more productive, provide more value in the same amount of time. So, lowering the overall budget of the project, and in some cases, making it possible to actually implement the project. Since certain things, more manual work would cost more, so it'd be more difficult to kind of meet timelines and budget requirements. So, it's a force multiplier for legacy expertise as well. The experts in natural and out-of-box are declining in the industry, right? Harder to find people that have expertise there. And Copilot is able to analyze the code, explain the logic of what it's doing, as well as help your developers be able to ask questions about the framework's platform and language as well. Microsoft has actually increased the legacy platform capabilities of Copilot in the last year or so, with it being able to understand natural code where it may not have before. So some of these items I mentioned, kind of our mainframe use case, a state agency payroll processing system, IBM mainframe, running natural out-of-box JCL batch jobs. So with that, there's not any automated tests of the existing system. There's no functional regression there. We need to preserve the business rules as it is. There's some documentation, but it's limited, right? So we have to look at the code. The Copilot will help analyze the code and identify what are the actual steps that the code is performing, and be able to parse through some of the syntactical difference of like data access code versus transformation logic, things like that, to kind of help increase the developer's productivity of understanding that original code. And then you can also compare the original code to the new code that was written and identify differences as well. The AI can do that much faster than a human. So some of those things, like it might take hours or days on some of these tasks instead of weeks or months. So it's really helps speed up that productivity. Yeah, like I mentioned, the documentation is the biggest problem. You need to modernize the system. You need to know how it works. Also, testing and validation. What are some of the edge cases that need to be handled? What are business processes or workflows that are run once a year, or maybe not even once a year, maybe less? Be able to identify those. Like a lot of the knowledge in some of those things disappear over time if it's not documented. So using Copilot, so you can use GitHub Copilot to understand the code, like I said, identifying the business rules, surface those edge cases. You know, it can help with writing code, it can help with writing documentation. So kind of all areas of what you might need to, the artifacts to build up as you're working on the project to deliver to the client. So for the migration process, they would, you know, maybe end up with, or likely end up with better documentation in the end than what they had to start with. And even some documentation on their old system that they didn't have before, which are things that might help them be able to test and validate, you know, the transformation there. So looking at the natural code to C# conversion on this project, you know, using Copilot to assist the creation of kind of development tools, automation tools. So one of the steps that we found really helps is instead of just asking Copilot to do the work, ask the Copilot to analyze and help you come up with an automation script to perform the work with certain tasks that are able to be automated. So you're able to do it in a repeatable, verifiable, rerunnable process. So like with natural and natural code, there's the natural programs, which is the coding logic of like a UI screen, and then the map is the definition of the UI. And we were able to use Copilot to generate Python scripts that can be run to do some of the parsing and interpretation of that code, so that it's, you know, like I said, it's repeatable, and we can test it and verify the results of it. Then we can work with fixing the scripts for the automation with any improvements that need to be made to iterate into the final scripts that'll help with the conversion of certain things. And then for the JCL jobs, or the background batch processes, or ETL jobs in the system, we can do the same thing. Some of the same thing with those to do those scripts. In this case, in the project, you know, the natural programs are being converted to C#, ASP.NET application. These background jobs with JCL, you know, we converted to Python to run in Azure Databricks. So using, you know, modern ETL tools. And then the scheduling, re-implemented orchestration logic there in C#. So we use, you know, Azure Functions to kind of re-implement the orchestration and the management of the schedules to run the jobs. So we're able to mimic the orchestration from the mainframe for what's needed to keep the same, you know, meet the same business requirements with the final solution. Not that we're completely redesigning or reorganizing the business processes for the jobs. They need to run the same, the logic in them needs to be the same, everything needs to be preserved so the same outputs can be verified to match the mainframe. Then UI transformation, you know, it's AI allows us to analyze screens, map the screen logic to UX patterns. So there was some outside of GitHub Copilot using like AI Foundry, we're able to build some tools to do some kind of more visual comparisons of the screens. In this project, with preserving business logic, they wanted to preserve functionality and usability of the application. So we wanted the web app version, the new modernized version of the application, to look and function the same as the mainframe app, but in the browser. The benefit of that is to reduce training of users on the new system. I mean, the scale of the system is over 2 million lines of code and over 1,000 screens and stuff. So like it's a large project to migrate or modernize, but also like to retrain everybody on all the functionality would take a lot as well. And And Copilot can help us generate tests, automated tests, as well as unit tests to help build up code coverage and validate that, or help us validate that everything works as it should. Help us with regression testing as we're making changes. So it's using a modern architecture. So the web front end in Azure Kubernetes Service, back end business processes in C#, Azure Functions, data in Azure SQL Managed Instance, Azure Databricks. There's some message-based orchestration for the background jobs with Azure Service Bus, and then the observability monitor and App Insights. So standard kind of resilience, BCDR type implementation of things in the cloud. Well, the solution doesn't use AI. The development process is using it a lot, right, to help us get there. We want to fit a incremental strategy for parallel running along with the mainframe, be able to replace module by module. That also is needed to be able to validate, compare. You need to compare the results of using the screens to edit things and the background processes that are resulting in the same end state of the data between the mainframe and the new system. Now looking at why does this work for government? So GitHub Enterprise, it's your own kind of private GitHub. Works well with enterprise there, helps meet some compliance requirements, private AI context with the tools. I mentioned we use AI Foundry, so it'll be a custom AI LLM for some things there that we're doing. And then with GitHub Copilot, there's the ability to use your own LLM within the development tools, and then there's on the GitHub.com part, it's a little more restricted to use their AI, but it's still like the enterprise grade security model, like multi-tenant from Microsoft, to make sure that there's no leaking of information and not using your data to train the AI. All the kind of standard things like that Microsoft adheres to.
Question. So since payroll, so when you have changes in tax and things like that, how does the system adjust for those like gap requirements and taxation requirements that you build into the process?
That can be a difficult thing. So the question was managing, making changes for like tax code changes, things like that in the system. With running the mainframe side by side, there's throughout the modernization process, we're required to get the latest code from the mainframe and then do comparisons with the last code that we got, and then go through a process to see like what changed, and then make sure we implement those changes in the converted system. So like while we're doing the modernization project, we don't want to modify the logic of the new system, because that'll introduce bugs or vary from what the mainframe is. And while the mainframe would be the kind of primary source of truth for the logic, but also the data as we're modernizing and transitioning, then the agency can make changes to the mainframe code, and then we can get the latest from them, what they release in their production in their mainframe environment, and then do a comparison. Basically, like file difference on the files. GitHub PR compares can help with that a bit, and then what programs changed and what logic, and then you can use the same tools to kind of implement those. Yeah.
Yeah, I have a question. So, is there a data server and an application server? Both have to organize, or
Yeah, like is there a data server?
Can you repeat the question?
So he asked if there's a data server and application server, so,
The question is, do you have to modernize both, even if that's the case, do you have to?
so like, for like a multi-tier architecture, like having to modernize both, like the full stack, you mean?
Yeah.
Yeah, well, I mean, the mainframe architecture is a bit different, so it's not really, front-end app, middle tier, back end. It's more, the front end with the screens has the logic built, the natural programs that power the screens are the front end app that has the business logic. And then the background jobs, the JCL jobs are the one like that, the background processes that have business logic as well. So like those are the two components.
I have a follow-up question, so
Yeah.
again, on the finance, this is finance administration, so legislation changes, federal policy changes, so when you have changes in finance and accounting, how are you getting those updates in, because they change, administration changes, you have to be consistent for that, so you're still putting in the mainframes as sort of truth and then copying it over? I don't understand that, why? Why not go to the new system and have updates automatically, why still the mainframe for that?
During the modernization process, if you want to rely on the mainframe for, in this case with verifying the business logic doesn't change and the, when the background jobs process an incoming file into the database, things like that, then, we need to make sure that it works the same. And while there's kind of a transition period while they're using functionality on the mainframe that they rely on every day.
So update the
They need
GASB.
to update that.
So update the
but-
GASB, go into the mainframe, the round process, and so go into the same system. I'm just trying to understand where is the efficiency in that? Why not go to a new system, leverage that capability, modernize that, and run all those new features and updates regulatory there?
Right.
Why, was it a business decision?
It's,
I'm sorry, I'm
no,
challenging because we
I
we're
got
trying
you.
to go through some modernization in our accounting systems and we're leveraging some Oracle people stuff. I'm just trying to understand why still have an older mainframe with a new system and you have all these regulatory changes that happen in financials, still putting it in this side and not putting it over here where you're building the new, unless they want it that way. I'm just trying to understand that.
Okay, you were doing this during the modernization process, right? Is this the?
It's just during the modernization process,
You
yeah.
have to run it.
So-
I get it, but
So you have to run it parallel in
say
the
that.
process
So
and then,
I'm trying to follow,
So right
it's
now,
not
they're,
clear.
right now they are in the new test.
so then once
That's
it's,
not clear. Sorry.
yeah,
So the mainframe solutions is running in parallel right now, so payroll's still running off the mainframe. We're also dealing with not just technology, there's state politics came into this as well.
I understand that.
So in June, they do their end of year something. This is the state employees with the tax laws, changes and fixes. So the official cutover happens in July. So that's why they're still making the initial tax
So in the
changes
end,
within.
all that we need to do is, I'm just trying to follow the journey because
Yeah.
it wasn't clear in how you're doing it. So eventually we'll get to the the mountain summit with the new stuff, right?
Yeah.
Yeah.
Okay, all right.
And an interesting side product, and I see there's another question, is that really, there was really no documentation from this system. So the team has been creating a whole new document explaining how payroll works and what the rules are, because many of these rules have been lost. And they also found in the audit, interesting, someone who was 1 year old, according to the system, who's getting payment, and someone who is like 140. So because of errors in logic of a system that is barely being maintained, we started uncovering, some potential savings for the state. I know there's a question, we do have another presentation coming. You also had a demo of some of the work done. But let's get, I saw the question down there.
Yeah, probably very quick. So obviously,
a lot of AI used on different parts of the project to make both analysis of behavior, analysis of data, but how much was the human in the loop factor here? Like, were there frequent interactions by humans looking at this during deployment, during production, or was it mostly autonomous agents kind of doing a lot of the work?
So I think Chris is going to show a demo. I'll just first answer that.
Yeah.
Human in the loop,
Show.
absolute. And it's not an AI that's doing it. It's AI is assisting the subject matter experts. Just quick story. So we have a mainframe expert, SME, on the product. In his 70s. By the way, one of the people at the state level that's still running the mainframe is in her 80s.
Wow.
So just to give you an idea, mainframes cost an amazing amount of money every month to keep running from a licensing perspective. So Jeff, we needed to move a lot faster. And Jeff said, well, I've been doing it this way for 30 years. I know how to do this. So he said, Jeff, we're gonna sit down, we're gonna show you how to put the code repository in place and get GitHub Copilot, and you can use this to analyze these millions of lines of code that it was actually double the amount because there was a lot of unused code in there. And it wasn't clear from the mainframe, it's just a dump of text files, what was being used and what wasn't. So we started showing him and he had that aha moment. It's like, oh, wow, this is saving me months. And then over the weekend, he played with it and he fell in love with the tool. So, we have an AI conversion. But with that, Chris, yeah, please go ahead.
Yeah, I think Jeff said he was like, in 2 weeks, he accomplished what he probably would in like 4 months, something like that. What we normally expect by having to analyze things manually. So yeah, with your question of the human in the loop, so it's the developers, the one driving it the whole way, and have to analyze the code and verify things. So we're not using Copilot to just convert this and then you run it and it just works. There's varying degrees of works after the AI runs through it, but there's manual verification and things that need to be done of the code, and running it, testing it. So we're going to show some of the components of GitHub Copilot. So I want to show like initially you have the plugin in VS Code here. So like install the tooling using VS Code. On the right here, I have a chat where I asked it, the original source for mainframe is located in this folder in my repo. For this demo, I just did that for simplicity, but I asked it, please explain the logic flow and what this specific program is doing. And it's able to go and it loads the natural code and then output and give you explanation of what it's doing there. Kind of a way to help the developer analyze it. And then you could go on from there to ask it to rewrite the code, compare C# code to natural and so on. But some of the real power comes in with some of the customization with GitHub, with Copilot. So one thing is, there's the agents markdown file, which you put an agents markdown file in the root of your repo, and then anytime you ask Copilot a question, it loads that context first. So you can use Copilot to write it. So as you're doing those analyze queries for the code base in your project, you can have it update the agents markdown for you. You can also manually edit it to add in context for developer best practices, code patterns you want it to use, any business knowledge that you want to make sure that the Copilot has on hand and understands in the context. So that anytime you query it, it uses that. And then the feature of Copilot that's just, I think, released back this last October is the ability to write custom agents. So you can create in the .github/agents folder, you can create markdown files that are custom agents. And this is additional context to create a custom agent that does a specific task. So you can have, like I have here, an agent that helps with code conversion work. I have files for additional ones for doing, code conversion analysis to be able to compare the original code to the new code. Agent for helping write unit tests. It can analyze the original code and help write unit tests for the new code to verify things. So,
We are at time, we do need to switch over, so if anyone's interested in, there's actually a whole series of tools that the team has created to make this whole process work. And Chris has a number of other demos, so maybe during the break, or we can always schedule another time, happy to go through that.